Okay, so this is Model Sim now. By the way, I have checked, and the same output that I got in this computer, the VCD out, the VCD file that I used in the previous, that didn't work on GTK Wave on this computer, and I checked the same file on my Mac. And it seems that GTK Wave on Mac was capable of opening that file and actually displaying everything in that file. So it looks that my system in this computer is somewhat, I don't know, maybe it's compromised or something. But anyways, I have to use Model Sim. I cannot use open source tools. Okay. All right. So first of all, I need to compile all the source. Okay, now you have check marks on all. Start simulation. And then select the test bench. Okay. Um, I need the clock. Oh man. It's okay. I'll just add all and then maybe this. Go. I don't want to add the real and the thing to the wave, yeah? I don't want to add them the wave. Control W, add them. And here I want the radix to be hexadecimal. Okay, so now I'm going to run the simulation for it. It's always advisable, Shabab. It's always advisable to run for 100 time unit, okay, or picosecond, because you may have an infinite loop in your code. So this way you'll catch it earlier. So let's run 100. Okay, you can see that my ready hasn't yet turned to 1. Okay, let's continue. Yeah, ready is 1 now. So this is the square root of 2. Okay, now we're using, by the way, we're using, what is it called? 16 bit of scale. Yeah, 16 bit of scale. So the accuracy here is more, okay, than previous time. So I can actually run since the I don't know. I just no. Oh, did I choose to run it all the way to the end? No, no. What is the usually the display error? Ah, oh, okay. It seems that absolute value is incorrect. Cannot execute undefined. I don't know why. Maybe what is the we can just let me pause the recording and look up what is the absolute value function for um, for model sim. So it turned out that using absolute value in model sim probably takes more than time than needed. So I just would like to see the error. Okay, we can just have compare this. If this is less than 0, okay, then answer is SQ minus GSQ. This is greater than 0. Sorry. Else it is the other way around. Here's G, here's Q minus here's Q. I need to close this. There is no need for the brackets, but better to. Okay, let's try again in Model Sim. I hope that it didn't complain about, it didn't complain about the square root. So going back here, I need to recompile. Okay, and restart the simulation. We'll go to the wave and simulate. Run all. Yeah, okay, great. You can see that here, the error is very small. The square root of 2 in the beginning, okay? And then 3, then 4, 0. 4 is, the square root of 4 is 2. So there is a 0 error here. And so on and so forth. It's very small. The error is very small. And this is using only 16-bit as a scale. And I think 16-bit is more than enough. If you want also, you can either select what we call either increase the scale or the number of iterations, okay? But that's at the expense of increasing the number of iterations at the expense of having more latency, okay? Having more latency. You can calculate the latency. I'll leave it for you if you want to calculate the latency. So the latency, you can start calculating it after this go here, after this one on go, okay? And then once you receive positive edge on ready, you just stop counting the ticks, okay? And this gives you the number of ticks between this place and this place gives you actually the number of clock cycles that that was required to compute the square root. Okay, I guess we are now ready to move forward with respect to implementation. So I'm going to also stop recording here and then move to another video to show you the debound circuit.